Hello and welcome to zwitterstat. In today's video, we are going to solve a problem on indefinite integral. So we have to integrate sine inverse x squared with respect to x. So arcsin x and sine inverse x are one and the same thing. You don't need to get confused. They are just one and the same thing. It's just another way of writing. Just sine inverse x and arcsin x, just other way of writing. They are the same thing, right? So the technique of indefinite integration that I'm going to use is substitution. Firstly substitution, and then subsequently I will be using integration by parts. So let's see how we are going to solve it. Firstly, I write u is equals to sine inverse x, right? So firstly I substitute sine inverse x as u, then I write du is equals to 1 over under root 1 minus x square. You know that the derivative of sine inverse x is 1 over under root 1 minus x square, right? Now one thing which I would like to clear at this stage only, that I have used the variable u, right? So, you can use, and I would suggest you should use z, y and any other variable instead of u, because if you are using integration by parts in any of the later stages, it may confuse you, right? And we will see why I'm saying this. So d equals to 1 over under root 1 minus x squared dx, that is the derivative of sine inverse x. Now we know u is equals to sine inverse x, so we can write sine of u is equals to sine of sine inverse x, which is nothing but sine of sine inverse cancels each other. We not cancels each other, but we are left with the x, right? So sine of u is equals to x. So I can write x is equals to sine u. So instead of x square I get sine square. 1 minus sine square is cos square u, right? And under root of cos square u is cos u. Taking cos u to the left hand side, we get cos u du equals to dx, right? So now writing our integral in terms of u, we get I is equals to integral u square cos u du. Now here you see, when I am writing integration by parts formula, since we are having two different functions, one is an algebraic function and other is a trigonometric function. So we can use integration by parts to solve this, right? So I take u square as my first function and u, right? Now here you may get confused that I'm stating u square as u. So u is just a representation of the function, right? We know integral u dv is equals to uv minus integral v du. That's the formula for integration by parts. So for here u in u dv, u here is u square, right? So that's why I was saying in a few seconds back that instead of u, you should use z, y and any other variable, as it will avoid any confusion when you will be solving the integral by integration by parts, right? So proceeding by integration by parts, I get uv. So v is integral of cos u. Integral of cos u is sine u, and u is as it is, so u square sine u minus, now v, so v is sine u, that is integration of cos u, and du is derivative of u. Now here u is u square, so derivative of u is 2u, so 2 comes outside of the integral, so I'm left with I is equals to u square sine u minus 2 times integral u sine u du, right? So here I get another integral, that is integral u sine u du. I here uh, I'm bound to apply integration by parts once again in order to solve integral u sine u du, right? So I name this integral as I prime or I dash, whatever you want to say. So again I take u as u, sine u as dv. Again applying integration by parts formula, we get minus u cos u plus integral cos u du, right? So my first function is u, so u as it is, and integral of sine u is cos u, right? So I get minus u cos u, and since integral of sine u is cos u, so here it was minus v du, so minus minus gets plus, and minus and minus is plus, and I am left with here cos u because derivative of u is 1 only with respect to u, right? So integral of cos u du is sine u, so I am getting minus u cos u plus sine u for I prime or I dash, right? So putting this I dash in my above this, I is equals to u square sine u minus 2 times integral u sine u du, so I get u square sine u plus 2u cos u. Why 2u cos u? Minus 2, so minus 2 times this, minus 2 times this minus u cos u plus integral cos u du is minus 2 times into minus u cos u is 2u cos u, and minus times 2 sin u, right? So I get this u square sin u plus 2u cos u minus 2 sin u plus an integration constant, since we are solving an indefinite integration. And instead of u, I have to, since my original integration was with respect to s, so I need to u was my dummy variable, so I need to write my final answer in terms of x. So we know that we have substituted u is equals to sine inverse x, so instead of u I'm going to substitute back, I'm going to reverse substitute u is equals to sine inverse x, so sine of sine inverse x, sine of sine inverse x is x, and u squared, so sine inverse x whole squared times x plus 2 sine inverse x cos of sine inverse x minus 2x, and plus there is a constant of integration, that is c, right? So this is my whole answer with the constant of integration c. I hope you like this video, and this video clears your idea about how we use integration by parts to solve an integral like this. In our upcoming videos, we'll solve more problems like this. Thank you.